Hello everyone, we're going to talk about the hot IPA vapor dryer and the Marangoni dryer fail issue. First of all, we're going to talk about the IPA vapor dryer. It's use the IPA here and I use the heater to heat and add some nitrogen to increase its process, and of course got to exhaust the high temperature IPA vapor just as we talked about before. This is the high temperature process. It is fair. The serious issue is after the process is completely still dry with some watermark and wet on the surface of vapor. So vapor not dry completely. There is some obviously reason we are going to talk about. First of all is exhaust pressure under setting value. This one. Too much density of the IPA vapor affect the process quality, and the nitrogen pressure here also affect the process quality under the setting or above the setting value. And the heater temperature control error. The heater can control, for example, the machine I have setting -72 degrees centigrade. It controlled about 34 to 70. If it is controlled error, to let the control out of range to be, for example, just like 85 or 67, no good. The heater temperature control, you have to see, maybe the setting value is okay, but control range is shaped. Next, the IPA concentration out of range. You have to check it out at the IPA supply. Especially from the facility Sometimes an IPA supply vendor also has some quality issue. We have to inspect from the vendor supplier. There is a strange, not open to see. The atmosphere pressure abnormal phenomenon. It made the fab pressure out of control. Also cause it. It happens with sometimes a very low atmosphere pressure, just like typhoon or hurricane, can cause it. Unusual to see, but still happened before. Now next, the Marangoni dryer. This structure we talked about last time. IPA tank, and then to supply to IPA tank to let IPA into, and also the nitrogen into, and the mixed vapor to spray and inject to the chamber, and move the wafer lift up forward slowly to let it dry. To each still dry fail. Why? Probably the nitrogen supply pressure out of range, or we can say below or above setting value. It can cause on dry. The IPA concentration out of range, just like here. Check from the IPA supply. And wafer lifter speed above setting value. This is wafer lifter. If move the wafer up speed too quickly, it can cause fail dehydration. Also, we'll just talk about it. Atmosphere pressure abnormal phenomenon. The same. The dewater process, drain speed error. Superior advanced improvement Marangoni dryer. Use. This is the water level. Is high. When the vapor up, the water vapor will slowly down at the same time. This is to enhance the dry function and make a throughput a little bit better. The water process strain speed error, especially water level drain speed too quick, it can fail dehydration. Okay, let's drop abnormal case to let fail dehydration issue. This is the workbench. The top is a HEPA here, or we can call it high quality filter. It sucks the air into the equipment through the filter. The HEPA pressure, or we call it sucking air flow rate. HEPA pressure is out of range, lower or above the setting value can cause it. Abnormal or this situation is not so serious, but still can cause not dry completely. And exhaust pressure out of range, below or above setting value. Exhaust can cause it also. Sometimes not so severely, but still can cause a little fail to dry completely. This is a strange but occasionally issue. The robot arm or the cover. This is an IPA dryer. This is a cover. The robot arm or cover gets pollution like a chemical or DI water residue. In this case, the responsibility not belongs to Marangoni dryer or IPA dryer. It just happened as the wafer moved out after drying process. The unpolluted by chemical liquid or DI water liquid also pollute dry wafer with the liquid residue. It's the same with a cover. It gets wet. Easy to say that the robot arm and the cover or something to get wet. It can cause wet pollution to the dry wafer. There is another strange issues. We'll talk about it later. Okay, let's all see you next time.